let's do section 7.5, exercise 27. Exercise 27, we're told we have a 20-foot chain again, 3 pounds per foot. So 20-foot chain, 3 pounds per foot. And hanging from a winch 20 feet above the ground. So right now we've got this thing, there's 20 feet. And find the work done by the winch in winding up the specified amount of chain. Well, in 27, we want to wind up the chain until the bottom is at 10 feet. So we want to wind up half the chain. So we want to get up like that. Okay. Again, similar to our exercises, I want to take the weight of a little piece of chain. Okay, so I could take the weight associated with a little piece of chain. Well, actually, now that I think about it, so this, the question is, do I want to start thinking about it starting at the top or the bottom, right? Because this chain, this piece of chain, it moves 10 feet. Okay, this piece of chain moves 10 feet. Right, so I have to move each of those pieces of chain 10 feet. But this piece of chain here, maybe that's at 15 feet to start with, it only needs to move 5 feet. Okay, so what I need to think about then is, how far each piece of chain needs to move. And I really have two separate pieces. There's the 10-foot part here and the bottom 10-foot part here. Well, these parts all move 10 feet. So I know how to do that, right? That's 10 feet of chain at 3 pounds per foot. So that's 10 times 3, or 30 pounds. And I'm going to move it 10 feet. So the work is 30 pounds times 10 feet. And so that's 300 foot-pounds. Okay, so that's the bottom part of the chain. Now this other chain, I can look at that and say, well, how much does it move? And it ends up moving all the way to the top. And depending on how I want to organize things, right, I could say this is 0 and this is 10. So I could call, each of these, there's 1, 2, 3. So it's not the way we normally write it, but I can take a given link. Okay, so a given link, the force is my 3 pounds per foot, but then times my delta y. Okay, and that link, each of these links, they move a total of y. So the work is 3 times that delta y, but then times the length I move it, y. And this is this case where I can use y, or I could have used 10 minus y, and it will work out either way. And we can check that we get the same answer. But so I want to do an integral. So part of my work, this part of the work, I need to use an integral from 0 to 10 of 3y dy. So that's 3y squared over 2 from 0 to 10, which is 100 over 2, or 50 times 3, so I get 150 foot-pounds. Now, what if I had used the 10 minus y? Well, it still would have been an integral from 0 to 10 of 3 times 10 minus y dy. Now why 10 minus y? I would have put 0 down here and 10 up here and said it moved that much, so it was 10 minus y. So this is 3 times 10y minus y squared over 2 from 0 to 10, which is equal to 3 times 100 minus 100 over 2, which is 50. So that's 150 again, so 150 foot-pounds. Okay, so my full answer, though, is I wish you all could yell at me while I'm doing the video. Okay, 300, right? 30 times 10 is 300. So the top part was 300, or sorry, top part. The bottom part of the chain that never got wound required 300 foot-pounds, and the top that did get wound required 150 foot-pounds. So my total work was the 150 of the top part of the chain plus the 300 of the bottom, or 450 foot-pounds. And that is number 27.